Okay, recording has started. We can get it going. Let me share the screen. So welcome everybody to this week's Gardener review meeting. We will look at the 1.138 release. And we're having 5 topics on the agenda for today. I will start with a feature in the Gardener node agent about serialized reconciliation of the operating system config. Then we have Nick, who shows us significant rework of the DNS in the local setup with the bind9 server. Then another significant rework in the setup and for the local development is the remote setup that was now introduced and replacing the old provider extension setup. Then we have Nikki with the application field in the ShootAdvertisedAddresses, and finally Sono with availability zone support in gardenadm. All right, then let me get started with the first topic. So this is about this PR here, which we worked on in this context of GAP28, the self-hosted shoot clusters. And I would like to walk you a bit through this documentation so that you understand the motivation for it. So this is about serializing the operating system config reconciliation for worker pools, which of course usually consist out of multiple nodes. And by default, this reconciliation happens more or less in parallel. So we try to split this a bit amongst, I think, 5-minute time window by default. We can also change that and, for example, disable this, which would then really mean complete parallel reconciliation. But yeah, it's not really coordinated in the sense that the first node has to finish and only then the second node starts and so on. This is actually good for regular or hosted shoot clusters and the worker nodes there. So we spread the load a bit amongst this 5-minute time window and eventually everything gets updated. But in the context of GAP28 and self-hosted shoots where we run the Kubernetes control plane as static pods on the control plane nodes, this might not be so great anymore. Especially, and this is explained then here in the second paragraph, when it then comes to updating etcd or Cube API server. Sorry about that. Because we actually don't want to disturb the quorum. And if we would, for example, update the second control plane node while the first one is still rolling out etcd and it's still in the phase of coming up or whatever, then we might lose the quorum and the cluster would be down and have an unavailability. So this feature is especially relevant for this control plane worker pool in self-hosted shoots. And with that we can coordinate the reconciliation, meaning that only one node starts to roll out the changes. And only when it's done, the others will do the same, but they are waiting for it. How this works is explained here. So there is the secret in the kube system namespace, which contains the operating system config as usual. And if you annotate it with this new setting, then you can basically enable this feature. And what then happens is very similar to the leader election that we are used to from controllers based on Kubernetes lease objects. So before starting the reconciliation here in this first step, every Gardener node agent instance attempts to acquire the lease. Only one of them can succeed, of course. Then this one reconciles, and this usually is not too long, but the lease is also renewed. So like the leader election, it has a timeout and it has a renew time and so on. So if it takes a bit longer because etcd takes more time to start or whatever, then the lease is kept. And all the others are waiting basically for the lease to be renewed again, released again. And only then they can try to claim it themselves. and the leader is only releasing it at the end when it was really successful. So when there is an intermittent error, it just keeps the lease and tries again. So this is basically it. More details are here in this document. You can read through it, but this is what I want to explain in this meeting. And then I would like to show it to you. What I have created here is, it's very fast to shoot with only one control plane node, because we are not yet ready with the full HA support. So I will show it to you with the worker pool that consists out of 3 nodes. So as said here, we probably will not use it for regular worker pools. We will rather use it for the control plane pool. But this is just for the demonstration, so that you can see how this works. These 3 worker nodes we see on the right side. So this is machine 1. Then here we have machine 2, and here we have machine 3. And we are looking at the logs of gardenadm agent. And what I have done as a preparation is I have added this annotation that we saw in the docs to the relevant secret for gardenadm agent for this worker pool. So when we look at it, that's more or less, then you can see the annotation here. So this means we have enabled it. What also already happened is that now there is also in the kubesystem namespace a new lease object, which has the same name like the secret containing the operating system config. And currently, as you can see also on the right side, all the node agents are idling because nothing has been changed yet. So there's also nobody which has claimed the lease yet. So the stack is basically empty. Okay, so maybe let's watch this lease object then here in this pane, and we grab for the holder identity so that we can see how this holder changes through the nodes. What I will now trigger here is just a simple change in the operating system config that will make them all trying to roll it out. What I did for the demo purposes is that I added another systemd unit here, which is just sleeping for 10 seconds so that we can observe it a bit. So every reconciliation should more or less then take 10 seconds. And we should see that the other pods that were not successful in acquiring the lease are just waiting for the one that has it to finish. Okay, so let's get started then. Here's this, I have a patch file where I basically add this systemd unit to the operating system config. And when I submit, we now see that machine 2 has gotten the lease. The others here see that it was acquired by somebody else and are now waiting. And now the 10 seconds are over. Machine 1 was successful with getting it. Machine 3 is still waiting. And now also machine 3 could succeed and could roll out the changes. So this is basically it. In the logs, you also see how the lease is claimed and renewed and released. So it should be easy to observe this and to check it later, how the order was, for example, if it is important. But this is basically the mechanism. The lease now is again, because every component is finished, lease is again empty and just waiting for the next change. Okay, that's all about the feature and all I wanted to show. If you have questions, please let me know.
Just a quick question. So that is required because static pods, there is no like Kube API server or whatever that could guard PDBs.
Yes, exactly.
Okay.
So we are just, when we update the control plane nodes, we have maybe a new pod manifest with a new version in the operating system config, and without this feature, all the control plane nodes would just write it to the disk, and then kubelet would more or less simultaneously try to restart, let's say, all the etcds, and that would not be too good.
Okay, thanks.
Okay. Then thanks again, and over to Nick for the DNS rework in the local setup.
Yeah, thanks. Hey everyone, I will just quickly share my screen. All right. Yeah, on this PR, I've worked together with my colleagues Tim and Martin, and basically completely overhauled the DNS setup in the Gardener local setup. So we've completely replaced the core DNS deployment with a now proper bind9 DNS server. That is the authoritative DNS server for the Zone local Gardener cloud. And as part of this, we've completely written the DNS record actuator, and we're now making use of something called dynamic DNS updates using the RFC spec 2136. This allows us to get rid of all the config map, core DNS reload stuff, and we are now able to support wildcard DNS records. And what I think the coolest thing is about this is that we can now get rid of nearly everything that we've had to manually add to the etc hosts file. So this is all now handled by the bind9 DNS server. And as part of this PR, we've added a small diagram that will help everyone understand better what's going on. As you can see in this diagram here, basically at the center of everything is the bind9 DNS server that is running as a Docker container. This is serving the Zone local Gardener.cloud. And whenever a client, this can be a developer machine or CI pipeline job, is now making a request to the bind9, we will have to configure a name server. And on macOS, we're using a resolver config like this. I've shown the output of what it includes here. On Linux systemd-based distributions, we can use systemd resolve config, and in CI jobs or for Linux distributions that do not use systemd, we can use DNS mask to make these configurations so they can use the bind9 to serve the DNS zone. And what is important here is that the provider local is now doing the dynamic DNS updates as part of the DNS record actuator. It still watches the DNS record objects in the cluster and will then reconcile them and send the DNS updates. So if, for example, a Gardener were to create a DNS record, or you would create one manually, everything would work nearly instantly. You don't have to wait for minutes until the DNS updates are propagated and all that stuff. So that's pretty cool in my opinion. Yeah. And I've also prepared a small practical showcase of how this looks. First off, I have to mention one small edge case that we've observed. And this is how we handle the registry stuff, the local registry stuff. As you can see, if I inspect the Docker container, we have configured a DNS name here that can be resolved by the local Docker DNS. And if I were to look into what is included as a DNS record in the local Gardener cloud zone using dig, I can see that for the registry, we have a name server delegation configured right here. So we're basically delegating it to the Docker DNS to resolve it. And this will only work from inside the kind cluster. And if I were to use my host machine with scaffold to push images to the registry, we've observed a small issue, and that is that in scaffold, I have to configure insecure registries to be able to push to the registry. And by default, only the localhost IP address is added to the InSecure registries. And we couldn't get it working with the registry domain or registry IP. So we had to implement a small hack, in this case, in etc hosts. As you can see here, we've basically got rid of everything else except for the registry that we still have to add to the etc hosts file. But this is still way better, in our opinion, than it was before, and way easier to configure. So these are the last two entries that we need to keep for now. So you can reach the registry from your local machine. Everything running inside the cluster will just use the Docker DNS to resolve the registry. Yeah. And as you can also see inside of here, these are all the records that exist. You will see the API server records for the Garden records. And what is also pretty interesting is that we also have the wildcard records here that we can now utilize for wildcard ingresses. And if I jump into a kind cluster, I can see here that these ingresses now make use of the DNS zone and the records that we have in the DNS zone here. And if I take a look at the DNS records that exist, you can see here inside the cluster that these all succeeded and were created automatically. And for demo purposes, I could now go forward and create a DNS record like this. This is just a small demo DNS record that will demonstrate that bind9 will immediately add the record. And if I were to apply this file now, I can see that the DNS record demo is created. And if I were to run dig again, I can also see that there's now a record that is being served by bind9. And it will also show the correct IP address that I've configured here. And now I could go forward and access it using this domain right here. Yeah. We've got rid of over 1,000 lines of code, if I'm not wrong. So we've cleaned up a lot of stuff, and we're pretty happy that we could contribute this to the Gardener project. So yeah, thanks everyone.
Thanks a lot, Nick. Any questions to the topic? Nope. All right. Then thanks again, and let's continue with the second rework of the local setup. Now the provider extension setup, which was migrated to the remote setup by Oliver.
Yeah, hello, good morning. I hope I'm sharing the right screen. Yes, it should be. Okay, yes, this is the second big rework in regards of development setups. Some of you might remember we have this, or we had this provider extension setup, which was meant for developing stuff which relies on real infrastructure, be it like provider extensions or maybe DNS stuff. And this setup was still using our control plane Helm chart. And as you know, the control plane Helm chart is deprecated, and we are going to remove it. And our development setups are one thing which prevents us from removing the Helm chart. So yeah, it had to be reworked, and yeah, that it's based on the Gardener operator in the future. And while doing that, we found out that it's maybe better to entirely replace it with a new setup. There was one thing in the old setup, it was kind of a mixture between a local kind cluster, which was working as your garden, your runtime cluster, and a remote seed cluster, which was running on the infrastructure, like for example, a shoot. And we had some workarounds to make the setup work. Like there was an SSH tunnel between both entities, and the workload identity deployment was somehow hacky because it was in the seed instead of the runtime cluster. And that's why we decided to completely remove this provider extension setup and create a new remote setup. And the remote setup is the key thing here is that everything is running in the remote cluster. So like when you use a shoot cluster, it will be a shoot cluster. So then this cluster will act as a Garden runtime and a soil cluster. Another advantage here might be that you can keep your setup running while you work on other stuff locally, and you don't have to be cautious or have fear that something is breaking your kind cluster, and then you have to clean up many things like domains and VMs and whatever in the infrastructure. Okay, so now I'd like to walk you through some new things we did here, or I did, in this PR. When you check out our documents, you might notice there's a new section, Getting Started Remotely. That's about the new remote setup. And there's kind of deprecation or removal notice in this Getting Started locally with extension setup. So when you have such a setup running, you should check out an earlier version of Gardener to stop it and remove all the things from the infrastructure. There's no migration path. It's so different. Makes no sense. It would be very complex. Okay. The whole setup is based on the Gardener operator and on our new dev setup structure. And I'm sure you can all read this document here. What I want to do is to walk you through some things here you have to consider, and you are free to read this stuff by your own. Okay, you see here now my Goland, and I opened up the dev setup folder, which is the new home of our local setups and also of this setup. And when you start working with the setup, you should look for folders which include remote. And so when you do it, you can, I think, go quickly through all the necessary configuration and find where you have to add things. One thing where you should start at is here, remote kube configs. That's the place where you should add your kube config. You should not use a Garden CTL based kube config. It does not work well with scaffold. You will see strange errors somewhere with like duplicated namespaces and so on. So don't use it. It's also written down in the documentation. Okay, so once you set up this kube config, you could start by running make remote up. And it will take this kube config and do a couple of things. One thing is it creates many configuration files. And while it's, I did it already before. So while it's doing its stuff, I will show you. So one thing, as I said, look out for remote folders. One thing is you have to add, so you should add some extensions, and again, remote folder. you will at least have to add, let's say, a networking extension, an OS extension, and a provider extension to make this thing running. And see here, that's my local setup. Yeah, consists of those extensions right now. And again, here we can continue with that. So there's the garden config, and so on. You find always the overlays folder and the remote subfolder, and certain YAML files. For each YAML file, we have those template YAML files, which are checked into the repository, and other YAML files, like here the garden YAML, which are in gitignore, which are for your local setup. And they might contain secrets you don't want to share. So yeah, be aware of it when you push things to GitHub. But usually in the gitignore, everything is ignored except the template files. So as long as you are in, as long as you are within this folder, you should be safe. Okay, and when you in order to start freshly, you should run this make remote first, because as I said, it's creating the YAML files. It's also creating sometimes things like empty YAML files for things you don't need, but you might want to use, like in this case, etcd backup. The reason for this is we are using Customize, and Customize doesn't like when there are missing files, but it's working when the files are empty. So there might be empty files, and this is okay. Usually we write it down like here. Okay, and short demo. So I remove this file in order to show that it's created again. And there's also like a defaulting or automatic set of certain values, which when you use a Gardener shoot, there are a couple of fields. I just remember here this nodes network. So I write something out here into the nodes header, and when I run make remote up again, you should see two things. So one thing is that this backup secret is created again. And the other thing is that the node networking stuff might be updated. If not, I did a mistake. No, it's not. It is. It was just too slow. Okay. Yeah. Good. So after you did that and prepared all the stuff, there are a couple of other commands like for the other scenarios, which is like make operator up to deploy the operator, make garden up to deploy the garden, and make seed up to finally deploy the seed. I won't run all of them, it will take a while. Maybe one thing which is important to know, when you run this make remote up, then at the end, your kubeconfig file of your runtime soil cluster is automatically copied to this place. And the kubeconfig, which is here, defines which scenario you are running. So when you now run, no, I don't want to delete it. When you now run make operator up, it will run a remote scenario. Let's start and stop. Here, detected scenario remote. When you run or when you start like a kind single node, cluster, then this kubeconfig will be replaced by this kubeconfig, and the next operator up will target your local kind cluster. But you can always come back to your remote cluster by typing in make remote up. That's what I wanted to say. Okay. And finally, I'd like to just show you that it is working. So I have a running setup here with one seed and one shoot cluster. Both are not that old, so I created them this morning. And when you check out what's running in this runtime soil cluster, you see that they are running provider extensions. So that's a hint that we are running a real remote setup on a not on a kind cluster, but somewhere in a real infrastructure. And you also see my shoot namespaces. And of course you can you should be able to create a kubeconfig for it, for the shoot here I mentioned, and kubeconfig. Oh, I forget which one. Kubeconfig. There's some notes. So this is it. Scenario is running. Maybe one thing. Currently, it's just supporting one soil because we still need this Kyverno stuff. There's a password protected registry where you push all your images, and Gardener does not support image pull secrets yet. When I raised this PR, I thought I might be able to deploy the Kyverno into other seeds via the static manifest feature, which Raphael presented a while ago. But now I learned that Shafiq and Ashish are working on supporting image pull secrets for Gardener Node Agent and later on for Gardener Images. So we might get rid of this Kyverno hack to ingest pull secrets anyway. So we might not do it. And if this is solved, you can easily create more seeds here, and you create managed seeds and so on. And then you would be able to create an entire landscape with this remote setup. Any questions?
Hello, Oliver. Thanks for developing this. I think it's a great improvement compared to the old setup, and also that we get rid of the SSH tunnel, which was a lot of pain. When I tried this out, so I also wanted to know, so maybe this is also related to what you've just said, if we could deploy multiple seeds or so on, because currently we have to copy, I think, the gardenlet and the garden YAML and so on for each infrastructure. So when I want to have one seed on GCP and one on AWS, I run it on AWS, and afterwards I have to copy all that config. So, and it would be nice if I could have just configured it the way that I could switch between the infrastructures, right? Because I want to test one feature on AWS, on GCP, and so on.
Yes.
Do you have any plans for some new iteration on that, or
yeah, I think so. So I will get in touch with Shafiq and Ashish how long it will take for this feature with the supporting image pull secrets, because that's the biggest thing which prevents us from creating seeds easily, because you have to deploy the Skverno stuff and the image pull secrets into each seed. That's a bit cumbersome. And when this is resolved, and yeah, as I said before, you can create multiple seeds in one infrastructure, and then I definitely will add support for it, that you can have like multiple seeds from different providers in your one remote setup.
Great, thanks. I'm looking forward to it.
All right, then I guess we can continue. Thanks, Oliver. And over to Nikki for the application field in the shoot advertised addresses. You can see the screen.
Okay.
Oh, no. Yes.
This is a very small addition to the construct of shoot advertised addresses that we have on our shoots. As you know, this has been a feature. This feature has been present for a while, and basically goes into the direction that we would like to have a mechanism where external components, tooling, or controllers which operate or know or are aware of shoot resources are actually able to also see what public endpoints or exported URLs are associated with that shoot. And currently, if you take a look into any shoot status field after access, which is up and running, then you can see at least those three endpoints who are advertised. So the external, internal, and service account issuer, and these are present. And now the story goes into the direction, what if I have additional controllers, gardener extensions, or anything else that can contribute to providing additional endpoints to a shoot existence. And for example, such controllers, at least in our domain, exist. One of them is a small OIDC apps controller, which is part of the Gardener ecosystems. And what it does, it actually manages some of the public endpoints of the observability applications associated with the shoot, namely Photon, Valley, and Prometheus. And we are able to actually access those applications using single sign-ons. And what this feature does, it's very simple. If we look right now into advertised addresses of shoot, then you see the name and the URL fields, which are already present. But there is one additional field which is called application. And you can see on these two URLs. And the purpose of applications is to carry a semantic which is not managed by Gardener itself, but is from the producer or the consumer of these applications. So, for example, in our world, we have a tenant-aware dashboard UI, which you can go and have overview of over any given shoot. And we would like to have dynamic way to accommodate these URLs in this tool. So this is a external to Gardener tooling, which consumes the meta information or application specific information from the shoot resource. And the whole story because behind this field is actually adding this application and how this value actually gets into the game. If we look into these additional resources, which are managed from external to Gardener controllers, like OADC apps controller, who at the end creates an ingress endpoints in the current implementation. If you look there, then you see a certain labeling. And what actually Gardener does, it goes and search for particular type of resources which has these type of labeling associated with them, and then expose that information or translate that information into the shoot advertise addresses. The whole concept is described here. It's relatively simple, but the main message here is that if you want to have a way to provide some kind of a non-Gardener dependent contract between these producers of these endpoints and external consumers, then there is a mechanism in Gardener that have these in place. And yeah, basically that's it. A simple label on an ingress resource can lead to actually exposing that into the shoot advertise address space. So yeah, that's the scenario, and yeah, that's everything.
Thanks, Nikki. Any feedback, any questions? If not, one more topic for today, the availability zone support for gardenadm zone.
Okay, so I'll be presenting this here, which is about adding availability zone support for self-hosted shoot cluster with unmanaged infrastructure. So coming to the problem first, the problem with self-hosted cluster with unmanaged infrastructure is that there is no CCM running, and CCM is the one which is responsible for adding those topology labels for region and zones. And in Gardener, we utilize those labels to have HA configuration for our workload. And since CCM is not there in unmanaged infrastructure case, if you want to run our workload across multiple zones by utilizing the Gardener feature of HA, then it will not be possible to fix this or to basically support HA configuration in unmanaged infrastructure also. This PI basically adds zone flags for Gardener init command and join command. So whenever you add a new node or you want to you join a new node in your self-hosted cluster, this you have to also pass a zone flag. There you can specify in which particular zone you are trying to initialize the node, and then that particular node will have all those both topology label. And after that, whenever the workload is deployed with all those topology configuration, which requires like spreading across multiple zones, this will be coming to the play. So for example, I'll go into the demo. I have set up this local setup with gardenadm and client setup. Also in the shoot manifest, I have changed, I have added zones. For control plane worker pool, I have added two zones, and for other worker, I have added one zone. So I've started the setup and I'll show you how does it look like. So if we get the resources, okay, I'll exit into the machine 0 and I'll get the resources which it should be initialized. And just a second, it's about time. Okay. Yeah. So, and if we see the shoot configuration on the files, you'll find zones here. So the control plane worker pool has 2 zones. And similarly, so when we try to start the init command, it should basically throw error because when multiple zones are specified in the zone configuration of that particular worker pool, it will complain that zone flag for that particular worker pool is necessary, and it also shows the error that supported zones are zone A and zone B, and zone flag is necessary. So I'll go ahead and add zone flag, and let's say I'll add zone A, and then it should be able to start the garden init command. And once the node is initialized, similar validation, similar support is added for the worker pool. So if you try to join the node using the garden join command, if there are multiple zones specified in the worker pool, then it will ask you to basically put like the zone flag is necessary. If there is only one zone specified in the worker pool, then it will enforce, it will put by default that particular zone topology level with that zone value to that all the nodes in that worker pool. And if there is no zone specified in that particular worker pool, for example, then this zone flag is not mandatory. So I will just I will execute the same machine where the node has initialized, and I will try to do that node. So far there is no node, but once the node is there, we can wait for another minute. Okay, yeah, the node is there. And if we see the joint node, the label should be topology level present. And there's a reason label. The support for reason label was added before in some other pair. And with this current pair, the zone level support is there. So since we initialized the node with the zone value zone A, the node has that particular label with the value zone A. And similar thing happens with other worker pool also. Yeah, that's pretty much it. We can wait for another worker pool check also. Like if when we do the gardenadm join, the same validation will come into the play. Meanwhile, somebody can, if there is a question, you can ask. Or we can finish it off if it was more or less it could work for the other worker pool also.
Yes. I was suggesting the same. Sounds reasonable. Okay, cool. Thanks, Sonu, for showing this. And yeah, with this, we are at the end for today. Thanks, everybody, for joining, and see you again in 2 weeks. Have a good time. Bye-bye.
See you then. Bye-bye.
See you. Bye.
Bye.
Bye.